All right, hello everybody, and welcome to the friction lab. And so in today's lab, we're going to be using these wooden carts, right? We're going to use two wooden carts. We're going to be using the motion detector, which is over here, and the force sensor, which is right here. And so what we're going to do is we're going to set this cart up to some location on the table, somewhere that gives us enough room, 15-ish centimeters away from the motion sensor, and somewhere that gives us enough room, about 15 or 20 centimeters, to pull the cart along in a particular direction. And so what we're going to do is we're going to start off by putting the cart on the table, and then we're going to mark like a little spot here on the table so that we know that that is our starting spot every time. So we'll make sure that we start dragging the cart from the same spot every time. This way, if there's any change in the surface that causes the coefficient of friction to change just a little bit, we at least will be starting in the same spot. So we should have the same kind of forces over the run each consecutive time. And so what we're going to do is we're going to start with the cart. You're going to find the mass of the cart using the scale, right? Both carts, actually, cart 1 and cart 2. And then we're going to start the run with one cart only, and you're going to put the masses in the center to keep the center of mass still in the center of the cart, right? And this way that you have equal, all the way around, equal pressure or down, equal normal force on the bottom, because on the bottom of this has just these two corks strips, right? And so we don't want one to be more on one side than the other. All right, so we got that lined up. We got that there. I've made a little string with 2 loops. I'm going to hook a loop here. And so, I'll tell you that in a minute. But we're going to hook this here, but we're not going to actually put any force on it yet. We're just going to let it kind of sit there. And so now we have our system set up, and we're ready to make our first run. So let's go to the computer, and let's start working on the computer. So we're going to come here. We're going to open the capstone program. All right. So we're going to plug the force sensor into the Passport 1 port at the bottom left-hand side of the 850 universal interface. We're going to plug the motion sensor into port 1 and 2 of the digital outputs and put the yellow one in number 1, the black one in number 2. And then we're going to come here to the table, and we're going to open that up. And as it turns out, the high resolution force sensor is already showing up. In most cases, that will be the way. If not, you just need to click on that, and it will give you a menu to choose a new one. So up here for the digital outputs for our motion detector, click on port 1, scroll down, and click on motion sensor. And so now our two things are set up. For the motion sensor, down here on the bottom, I want to change this to 100 hertz. And I'm going to click here right on this drop-down sensor, and I'm going to go to high-resolution force sensor, and I'm going to make this also 100 hertz. Okay, so now we have that set up. That's all set up. Let's click on Data Summary here on the left-hand side. And for the force one, click there and click Change Sign, because we'll be pulling one way, and the cart is resisting that pulling. And so when we look at this system, right, we're going to be pulling this way, and it's going to give us a negative if we do that because the cart's pulling that way. So we'll just change the sign, and that should put everything right. Okay, so that's done, and that means everything is now set. Now what we want to do is on here you can see that there's a 0 button. So make sure there's no tension in the string or anything like that, and press the 0 button. And what that's going to do is it's going to zero the sensor. It's going to say, okay, this is the base force. Anything now that we apply is going to be like an added force, or the measured force, right? And we also want to, over here on the drop-down menu, we're going to switch back to motion sensor. And once we get our motion sensor, which we see here in the spot that we want, well then we're going to click this 0 sensor now. And you'll hear a couple little clicks, and that's just basically saying, okay, this spot from the sensor to the cart is now 0. So as the cart leaves, it'll get farther and farther away, starting from 0 to 1, 2, 3, so on and so forth. All right, so now we have everything set up over there. Let's go up to the graph, and let's double-click the graph icon on the left-hand toolbar twice. There's 1 and there's 2. So on this first one, we're going to select the force sensor. And on this second y-axis over here, we're going to click velocity. And so this is going to give us our velocity over some time. And this is going to give us our force during this same time. And so now everything is ready to go. We're going to click on the record. And what we're going to find is we're going to have to pick this thing up so that it's kind of level across the table. And we're going to start pulling on this thing. And we're going to pull it so that you just feel the tension in the string, and tension in the string, and tension in the string until it starts to move. And then once it starts to move, keep it moving at a constant velocity. And you'll actually use the graph, the velocity graph, on the capstone to kind of keep that velocity even, right? Okay, so let's do a demonstration. So I'm going to click. We've got it in the start spot. That's already set up. The force sensor has been tared. There's no force on it right now. I'm going to press record, and I'm going to start pulling on this thing. So it starts going, and then I'm going to keep it going at more or less a constant velocity. All right. And then stop. And so here, what do we see? We have more or less a constant velocity. All right, we can kind of see that we were keeping it at about 0.04 meters per second-ish. And here we can see perfect example of what we should see. We see I'm going to go ahead and make that so that it's centered. And you can see, okay, we have the force goes up, goes up, goes up, goes up until it reaches a maximum. And at that maximum, that's when it finally starts to move. In other words, we overcame the static friction. And then it drops down, and as we keep it going at a constant velocity, you can see that the force required to do that remains about the same. And so we're going to come here, we're going to use our coordinate tool. We're going to add a coordinate, and we're going to move that up here to the very top. And so this is our top value. This is the top force, or the highest force that's achieved, or the maximum static force, right? And then we're going to come and we're going to use the highlighting tool, and I'm going to bring this over here. And I'm just going to highlight this area where we had the forces basically the same. And I'm going to click on this summation sign up here, arrow, and I'm going to make sure the mean is checked. And if it's checked, I'm going to go ahead and just click on the summation sign, and it'll give me the mean. And so that is the mean force required to keep it moving at a constant velocity. And so if we have that all good, we record those values, we reset the cart, and then we add 100 grams right in the middle. And we're going to do this again and again and again. And so we're going to do 5 runs. I'll do them real quick. Okay, so now we've done those runs, and we can go back and we can do the same thing with each one of these graphs. We can use the coordinate tool, we can find the max force, we can find the mean of the kinetic force for each of these runs, and we'll record all those individually in our tables. Now, with that being said, once you've done that, we're going to keep doing this, but we're going to do it with two other configurations. One is going to be we're going to add a second cart. And the second cart, when you come to class, well, this one will actually have another hook here. And we'll just hook these two together like this, move this motion sensor back a little bit. And what we're going to do is we're going to do the same pulling again, but we're going to split this up. We're going to put 500 there and 500 here. And what are we trying to figure out now? We're trying to figure out if this increased surface area, right, with this increased mass, or with the same mass, is going to make any difference at all. Right? We still have 1,000. We still have 1,000 in each one, although we have the additional cart here, which we'll take into account here in a minute. And so now we're going to do the same thing again. We're going to do 5 runs with the different weights. So we'll do one run like this. We'll add 50 to both sides. We'll do another run. Then we'll add 50 more to both sides. We'll do another run. Then we'll add 50 more. We'll do another run, so on and so forth, right? And we're going to use the same weights throughout. Then, once we've finished that set of runs, we're going to take and stack the carts. And so the last one will be with the cart stacked. And we're going to do the same principle again with the stacked carts. And so we've got one cart by itself. We've got both carts together, basically the same mass, just a difference in the cart. And now we've got both carts together still and stacked on top of each other. And so now we'll do the run like this. We'll add 100, do the next run, add 100 more, do the next run, 100 more, the next one, so on and so forth, right? And so we'll just do that until we have all the runs done, and then we will record all our data and finish the lab, the questions. All right, guys. Well, I think that's it for this lab. And with that being said, see you in class.